Now we are going to go back to the presentation of VODAN 2023, and I'm going to give the floor first of all to Samson Yohannes from the mechanical team for that. And Samson is the technical lead for the whole team across Africa and Europe and Asia. So Samson is working very closely with VODAN in the fronting of the technical strategy. And at the moment, they're making the transition from the production, the data production in the health data space to the use cases together with a team of Microsoft. So that is the front team, but behind them are many others who have allowed that tooling to be in place. So Samson, I think we should be able to see you if you could turn on your camera and your audio. Welcome, Samson. So it's really a great pleasure, Samson, to introduce you. As I said, you're lead from Mekelle University in Ethiopia. You are a PhD student from MMC, and you are going to take us through this report on VODAN-Africa 2023. Thank you, Samson.
Thank you very much, Prof. Can you hear me? If you guys can hear me, I'll try to quickly present what we did as VODAN-Africa. Before I start, I'd really like to say that it's really an honor to be presenting on behalf of VODAN-Africa team, and thank you, Prof, and the whole team. The presentation is going to be given by the first part by me, and then Professor Miriam will continue. We'll talk about what the architecture of VODAN-Africa looks like. It has been evolving from start, and then I will try to show you what the current state of the art looks like, and then I'll try to dwell on how we're moving with the data production using that architecture, and then how we want to build a business case around the architecture so that it becomes sustainable and then beneficiary to the health facilities, and also talk about the data stewardship program that supports it, and so we'll also talk about the governance and the way forward. Next slide. So the architecture of VODAN-Africa now looks like this. It's a layered architecture where on the bottom layer you would see the data layer, which tries to produce a single copy of machine actionable data. Here we use vocabularies. We try to produce fair data in residence. This layer is being used by the health facilities that are enrolled in VODAN-Africa network, and each country produces a linked data and then exposes a knowledge graph to others. This bottom layer where the fair data is produced can be used by the layers above it, or we build an infrastructure layer on top of this layer, and then on the infrastructure layer we've been exploring on how we'd be hosting services, on how for instance we do federated analytics, and then what kind of software and hardware infrastructure do we need to build around this, and how the possibility of local and global cloud. And then on the right side, you see that the federated data space needs to be managed, needs to be interoperable, and then also, most importantly, there needs to be a regulatory compliance in place, because we're dealing with patient data, which the privacy needs to be protected, and then there has to be a way that we comply to each of the health facilities. Once the data layer and the infrastructure layer is there, we build the knowledge graph, or the knowledge generation, or the intelligence layer on top of this infrastructure, where we try to also allow others to build other applications, interact with our platform, and provide or build services on top of it. And then different doctors and individuals can experience our platform. So this layer is where you will have the user experience and intelligence layer. Next slide. So the layers are not separate as such, because the data producers, in principle, as per the principle of VODAN-Africa, needs to be the primary beneficiaries of the data that they produce. So what comes out as an output from the intelligence layer goes back to the data production layer and to the health facilities. And then we have the service layer also interleaved with the two layers. So it's not hierarchical. And then beyond the FAIR principles, where we try to make data findable, accessible, interoperable, and reusable, we try to what VODAN-Africa believes in that all the tools and the services that we build need to be localized. They need not be away from the local context. And when ever possible, they need to also be locally deployed on the facilities. They need to be owned, and then they need to comply with the regulatory frameworks of each of the countries. So, basing this architecture, what we have been able to achieve or realize so far is we've been able to, by creating sets of tools and techniques that are useful for this purpose, we've been able to produce FAIR data. We've been able to do remote federated queries to the facilities. We try to see how we comply with the different regulatory frameworks of each country, and also we try to build a data stewardship program so that it gets sustainable. Next slide. So now I'm going to speak about how we build the different communities around this, because each country, at the bottom layer, you see sets of facilities here. For instance, in the case of Tigray, we have about 10 facilities who are going to be who are working on this. So we have sub-communities also, and within the communities we can do federated analytics. You can do it in Kenya, in Uganda, Nigeria, and other countries, but also we can do cross-community interoperability, where we have multiple data spaces that are placed in a federated manner. So we do within community analytics and then across community analytics. And so far, we've been able to achieve this process by producing FAIR data at each of the facilities, and then trying to do federated queries. And at later stages, we have also been able to train models and build models. The beauty of this, or the importance of this, is that imagine you have a disease outbreak or something that you want to explore. The data that you have, for instance, at facility A, at facility 1, may not be is enough to build a model, but you can build a model based on data from 1 up to 3, and then the results of the model can get back to facility 1. So you are able to learn about some sort of a disease or an outbreak that's happening in a collaborative manner, because different facilities are sharing knowledge towards and then also producing new knowledge as a result. Next slide. So what we are now moving forward is, of course, by being compliant with the legal regulatory frameworks of the different facilities, we've been able to have access to patient data, but in some places, or the way we envision moving forward, we also want to empower individual or personal data pods where you would be able to do federated analytics, but with individuals having a direct control over their data. Next slide. And so this is where you see the different concepts where Putu was also trying to explain earlier on security, privacy, consent, and the likes are being handled at each of the individual levels. Next slide. So this way, we can have different facilities who would accept or decline to be part of a federated analytics, depending on the different situations. Even when because of infrastructure, when some node is down, the modeling should be able to continue. And then this is where we trying to show the federated concept. Next slide. This architecture or this drawing tries to indicate the different tools and that we have been using as VODAN-Africa. As VODAN-Africa, what we try to avoid is vendor locking, and then we always try to look for new ways of dealing with the problems at hand. And across the years, the different tools and techniques that we've been using have been evolving. But in the year 2023, also we have used BioPortal to host our vocabularies, and there are different tools such as CEDAR, Allegograph for triple store, and there are also software tools that we created, such as the bulk upload tool. And then because many of the facilities have also been using DHIS2, we've also used DHIS2, or we try to make our system interoperable so that it sends reports. So the different facilities are fitted with different software technologies that allows them to be able to conduct federated analytics. The latest tool-wise that we used is the PySift, which is a federated infrastructure for federated analytics and learning. Next slide. So using these tools, what we are moving towards is that each facility tries to produce their data, and then the data becomes linked data and becomes a knowledge graph. So I'm going to talk a few minutes about also how we deal with this process of creating this knowledge in the facilities. Next slide. So we have different templates that are being used by the facilities. For instance, it could be abstract registers or data registers that are being used in hospitals, and then these forms are converted into much actionable forms, and then converted into RDF or JSON link data format, and then they are stored in a triple store. And the different triple stores, indeed, the different facilities would be exposed through an API where they can be queried from externally. We have an access control in place, and also, of course, de-identify the data before it's available for a query. But this is the whole process of the data. Next slide. Yeah, so technically, if you look at the Kenya template, if the terms in the templates they exist in the vocabularies exist, we use them from Bioportal. But if they are not available, we use Excel to create the SCOS files and then convert it through SCOSplay into RDF and then do Bioportal and then we create we create templates which are able to create link data as the data is being stored. Next slide. So through this process, even if we have so many facilities, you can think of this as a sub-community concept in the federated analytics that I was presenting. We try to create sub-community from our community so that we create and test in-depth quality data. As part of this process, we've enrolled in the 2023 Kenya, Uganda, Nigeria, and Ethiopia. As part of the quality data pipeline, where we try to do analytics on pregnant mothers follow-up and also outpatient data. Next slide. So through this process, the countries were able to collect antenatal care data, OPD data, and then this data we converted into a knowledge graph, and then the numbers you see here are the triples that are created based on the data that each of the facilities are creating. We're focused now on antenatal care. These are real patient data at point of service. And also we beyond the patient data at hospitals and at point of service, we also have we do fair by design and fair by increment. The one you see on the left is you can say fair by design, and then the one on the right is a fair by increment, where we have, for instance, NICU patient data, national aggregate HIV and HPV data, refugee data, from media reports, from interviews on migrants in Tunisia, and also from vaccine trials, and many more research data is being verified and then is being analyzed in a federated manner. Next slide. So in the facilities in the mini pipeline, we have enrolled this facilities that you see, and the pictures you see on the right are screenshots of their data, their knowledge graph on AliGraph. So from Nigeria, we have Railway Clinic, JH, Laipai, OOU, and Fall. In Kenya, we have Pwani, Beacon of Hope, Lira, and also Arki and Kampala International University from Uganda, and Hoima, and Aido Referral Hospital and Magale Hospital from Tigray, Ethiopia. Like I said earlier, these are not the only facilities that we're working on, but these are quality data pipeline that we subsided, like a sub-community creation and then federated learning within communities. That's what we're trying to experiment, and then we would want to create other communities and also broaden the scope at a later stage in our next slide. Yeah, and the data stewardship program, we have, because this is a new concept, not only for Africa, but I think it's globally, it's new. Even the FAIR principles, or FAIR itself, has not even celebrated its 10th anniversary. It's going to celebrate this year, next year. So there is lack of capacity in data stewardship, specifically on FAIR data. Cognizant of this, VODAN-Africa has been engaged from low level, and you can show the next slide, from low level data clerks, starting from equipping data clerks on how to handle and manage data. We have certified data stewards from level 1, level 2, 3, and 4, which I think are going to be some of them. Last year we've graduated 30. This year we'll also be graduating. I would really want to also, I think would want to recognize the support that was given by Nuffic. We have we had a program called DISH, Digital Innovation Skills Hub. Beyond the data stewards, we have been able to train thousands of students across 6 countries. If I'm not mistaken, about 11,000, where we taught them computer science level 1, level 2, and level 3. And then through this program, we identified a need to develop an advanced course. We called it Course 12, where we try to deal with advanced data stewardship concepts. And then I think today level 4 graduates would be announced. But below, starting from the low level, this capacity building, we have many PhDs that are engaged in this process. The list that is on the right is a number of PhDs that are directly engaged with VODAN, including myself. Next slide. Yeah, I think I would love to end here, cognizant of the time. Thank you very much for your attention.
Thank you very much, Samson.